In this video, we are going to see the graph for tan x and cot x, and for that we are going to help of sin x and cos x because we know that the tan x and cot x are basically coming from on sine and cos, right? What we can do here, let's say we have a we are just drawing up to 360-degree positive and negative direction, and let's say this is our uh, we are putting both sin x and cos x. Okay, for tan x, uh, we are just doing the tan, right? So, and this is our x and this is our tan x, and that is our graph that we need to do now. And let's say this is our, for example, this is our -1 and -1 +1. Okay. Now if you look at tan x is basically sin x over cos x, right? Cos x. So from that relation you can imagine if the denominator cos x is 0, if the denominator is 0, then you are getting vertical asymptote, right? So when the denominator is 0 is undefined, anything over 0 is undefined, or divided by 0 is undefined. So it means you will get asymptote in that point. So where cos is 0, if you go cos 0, cos graph is a blue graph, so cos 0, where the cos 0 is, cos 0 is at 90-degree position, so I can put a asymptote here at 90-degree position is asymptote. Cos 0 is 120-degree position, it is asymptote. And then cos 0, if you come back to minus 90-degree, is a asymptote, right? And cos 0 is here at 270-degree, which is asymptote. Okay, so this is 270-degree. And now what we can do, you can see here that when sin x is 0, then tan x will be 0. So when sin x is 0, tan x will be 0. Where is that happening? Sin x will be 0. I'm just putting it in black color. Sin x will be 0 at the point where here. Okay. Sin x will be 0 at 180-degree. Sin x will be 0 at 360-degree. And the same way it will be here and then here. Okay. At 370-degree. And now what will be the graph then? If you see that the graph is coming here, and then you know that 10 is positive in the first quadrant of obviously. Also check what is tan 45. So this is 90-degree. We know that it's a 90-degree. So what is tan 45? Tan 45 is 1. So it is basically giving you the graph another point here. If then is, you can see that the graph is basically connecting these 2 points, right? So if you connect these 2 points, right, that's the one, and then it is going like, when it's going closer, it would be just going like up, right? So that would be the graph, right? Okay. And then same way, if you do the other way, it's -90-degree is -1, so -45-degree. If you go -45-degree, you will get -1. So here is another point, and if you plot the graph, it will be like just connecting and then going to the straight down, right? And then if you go for above 90-degree, then you will get the same pattern, because at fourth quadrant, this is first quadrant, second quadrant, third quadrant 10 is also positive. So again the graph will be, and you can see it's like just it's moving like a parallel pattern, right? So it will be going, and then it's going close to that one and never touching that, right? It's going kind of vertical here, and then the same way it is coming down here. Yeah. Okay, and the same pattern you can observe here as well. So if you just do that one, okay, and make sure that the gap is the same. Basically it is basically the same pattern, and if you go to the negative direction, you will see the same thing. It will be just going up and then it's coming down to that side, right? Same thing. Now if you look at that graph, you can see that pattern is repeating. If you consider from here to here, you can see it's a 180 degree, or if you go for any point 90 to 270, 180 degree. So in this graph, the period is 180 degree. It's not same as cos and sine. We had the period for 360 degree, and here it's every 180 degree the graph is repeating. Okay, and this is for 10x. Okay, and now if I do the same for the cortex, then you can see the cortex is just a reverse relation, right? So when we are doing the cortex, let's say we have a graph for cortex, um, x, and this is our 360 degree, and I'm just trying to write down the relation for cot is just reciprocal of 10, and we can write it's a cos x over sine x. And in that case, the asymptote you will expect where sine x is 0, because the denominator is sine x. So where the sine x is 0, so if you look at the sine x 0, sine 0 at 0 degree, so this is our one asymptote. I can put the asymptotes now with the red color. So this is our one asymptote where sine x is 0. Sine x is 0 when it is 180 degrees, so we can see the asymptote will be 180 degree, and sine x is 0 when it is 360 degrees, so asymptote will be at 360 degree. And the other way again is, you can see again is sine 0 is 180 degree negative, and negative 360 degrees, so it's here. And where cos x is 0, that's the point you will get the graph, right? So cos x is 0, we can see the cos x 0 at 90 degree, cos x 0 at 270 degree, cos x 0 at minus 90 degree, minus 270 degree, right? And now if I draw the graph, and you can see that in the first quadrant we have a positive. So like, let's say we are going for cot 45 is 1, obviously it's a 1, cot 45, and cot negative 45, if you go negative 45, it will give you minus 1. Okay, and for positive 45, it will give you 1. So it means you have a point here. It means you have a point here, and then if you add this, you can see the graph will be like that. Okay, so it's just adding the point like that, but you are getting the graph, and then it will be straight or parallel to up, like it will not touch the red line, it cannot touch the asymptote, and then way up down, and then going like that. Okay, so same way you can just copying the graph, and make sure that there will be equal gap, so it should be equal shape, right? Same shape, and the same way you can just repeating that. Okay, and they will never touch that, it will be just coming close to that line, right? So same way you can just coming like that, and then going like that, and then going like that, right? So you see the graph is coming just other way around from the 10x, and again the period you can see every 180 degrees repeating. And in these two graphs, we are not talking about the amplitude. Why? Because the graph is just going near the asymptote, is just going up and up, okay, without stopping or without any boundary. So we would say that there is no sense of talking about the amplitude in this case. Thanks for watching, and if you'd like to see more up-to-date videos, please subscribe my channel.